A warm greeting to everyone. I am D.M.KALAI SELVI, Assistant Professor, CSE Department, RMD Engineering College. Now we are going to see model representation and interpretability in machine learning. So under machine learning, we can able to see many algorithms. So how we are going to represent it, that we are going to see the methods in it. First one, underfitting. A statistical method or a machine learning algorithm is said to be underfitting if it is as too simple to capture the data complexity. That means if you have the underfitting model, you're saying a model as underfitting, it will have high bias and low variance. So when we say a model or a machine learning algorithm as underfit, but if it has more training data and also it reduces the features to produce the effective feature selection. A statistical method is said to be overfitted. Second topic we are going to see overfitting. When you are saying a machine learning algorithm to be overfitting, when it does not make accurate predictions on the testing data. So when we have a overfitting is if we have high variance and low bias. Overfitting can be avoided by using the methods like resampling techniques, k-fold cross validations, and other than that, you have many validation data sets and remove the nodes which have little or no predictive power. These are some graphs regarding the underfit and overfit, and we expect a machine learning algorithm should be a balanced fit and should not come under underfit or overfit. If we see this graph, if your algorithm we are saying it is underfit, the data sets, a straight line will be drawn, and you have a partitioning of dividing the data sets, and you have data set over and under that line. If you go for overfit, the line will be very curved, and which means it allowing all the features and all the data set, and our data set will be overtrained and we can't get the accurate data. So we are going for a balanced fit. So balanced fit means even if it is curved, it will not reach all the features. Some will be beyond the boundary. So that was the perfect example for a balanced fit. Another metrics we are going to see in is bias and variance. In supervised learning, the class value assigned by the learning model is built based on the training data may differ from the actual class value. So two types of errors, one is bias and one is variance. So bias is due to underfitting and we have high bias due to this method. And variance is due to overfitting as we have many different data sets, different types of training data sets, which relates to overfitting of the data, and we use the term variance. So this is an example that shows the bias and variance and low bias, low bias, high bias, low variance, and high variance. And for a perfectly fitted machine learning algorithm will have low bias and low variance. So this will be the correct picture. Thank you.